Hi everyone, so we're back today with the Raptor system. We're going to do some dry powder analysis. We're going to do a little bit more in-depth work with the dry powder system, and we're going to actually record the video on the screen as we do it. So right now I have the Raptor dry powder module sitting on top of the instrument, but this is our wet cell. So we were running a wet sample a little bit earlier. We took the tubing out. You just take the wet cell out and you put the dry cell in with the little funnel that we have on top, and that's it. You're ready to run. Go ahead and put the feeder up on top, and you'll see the light turns on, and you have the vibratory setting right here. So what we're going to run today is we're just going to run a little bit of starch that I have from a customer. So I'm just going to scoop up. This is kind of small. It's a little sticky. So we'll see how it works. Sorry for the ringing of the doorbell there in the background. So I'll just put a little bit, put some in there. We got plenty here, so we'll put some in there, and we will cover this up. And then I just put a sample name called DP6. What I'll do now at this point is usually I'll test. I'll test to see how it goes. So I'll do an analysis the long way, and we get to the image screen, and let's get, we're going to go ahead and apply image. And then what I'll do is I'll do the preview of images. When I do the preview of images, what I'll do now at this point, I'll start feeding and turn on the vacuum. So when I turn on the vacuum and I start opening up the feeder a bit, I'll start seeing some samples come in. And you don't want to put too many, because if you have too many in the same place at the same time, they'll show up as agglomerates or clusters. So what I'll do is I'll take any image and I'll analyze it, and I'll increase or decrease my focus rejection based on whatever I'd like. So I can increase my focus rejection, decrease it. But let's say I'm okay here the way it is now. I can just do next, then just start the run. And right now we're just looking at circularity, which is 0 to 1, and we're looking at size. So this is a number weighted distribution going from 20 to 2000. We also could look at the volume weighted distribution as well. So the sample hopper will continue to feed sample. I'm going to see if I could really quickly bring the camera over so you could look at it. So here you can see the vibratory feeder. I'm not sure if you can see the vibrating, but it does actually feed in there. And then I'm not sure if you can see underneath. Kind of hard, but you can see the particle going through. And I think we have it set up to capture about a minute's worth. So we have about 3,000 particles now. So at this point, what I'll do is I'll just turn off the vacuum, because it's noisy. And then at this point we could do a lot of things. We could look at the different settings of the different classifications, so we can move these out of the way. We could look at all the thumbnails. We could do correlation plots as well. So we can just close all this. We could do a correlation plot, which is right here, and do a correlation of all the particles by any two different parameters. You could do circularity by size. This is perimeter circularity by size. You could look at smoothness by size. This is actually a very useful tool because it allows you to kind of find the needle in the haystack, is the concept. You'll find maybe some particles of interest that you said, wow, why are these have such a low circularity? They seem to be the smaller particles, whereas the larger particles seem to have a higher circularity. You could look for things like that. A lot of other tools here, which we're not going to go well into, but yeah, definitely you can look at classification. This is a default classification. You can set up a different classification, and I got great videos on classification. This doesn't really have any meaning, but you can actually set this up so you can look at how many of the round particles, how many of the not so round particles. You could set that up. So everything goes on here in your dashboard. So again, you're looking at a volume weighted distribution. You could also look at the number weighted distribution. You could look at both, and you have all of your statistics. When you look at the large display, you actually have the ability of zooming into any portion of the graph and looking at the statistics and the actual counts in that area, just in that region. So let's do another run. It's real quick. So I'll just get this sample run. I will create an increment. And again, I will just turn on my vibratory feeder to what it was before. And now, since I already have my settings set up, I'll just do a quick start. And the quick start will automatically just start a run. Again, if I had too many particles in the same place at the same time, what would happen at the end? I would actually show clusters of particles in my thumbnails. So again, very useful to look at your number weighted distribution, but also very useful to look at your volume weighted distribution. Oh, and I forgot to put my vacuum, so I probably have some sample accumulated down here. So that's a nice thing. You don't really necessarily need the vacuum cleaner to actually do the run. It just clears out the things on the bottom, and it does collimate it a little bit better. So in this case, you did get some agglomerates there. So I would probably discard this run, and I would do another one with the vacuum on. Let's do that. Again, increment just gives it a new name, a dash, and you just start the sample. It's that easy to run a sample on this instrument. Again, number weighted and volume weighted. At the end of the run, you have your thumbnail images that you can go through, and you also have the ability of looking at all your different statistical histograms, circularity, bounding circle, circularity, smoothness. And again, everything happens here in your dashboard. The dashboard is where you actually do a lot of the, this is where all the tools that come in for the user to take advantage of the fact that we are gathering 32 different more than 32 different shape measurements for every single particle, and being able to differentiate subpopulations. So there's how it runs. Pretty simple. When you're done with the sample, you just turn it off. You go ahead and just remove it off the platform. And then at this point, you just take this off, you dump it out, blow it out, and you're ready for the next sample. So I hope that was helpful. If there's any questions, let us know. We'd love to run some of your samples. Thank you.